In this question, it says, in each row, check the box under the compound that can reasonably be expected to be more acidic in aqueous solution, e.g. have the larger Ka. So the larger the Ka, the more acidic something is. And in each case, I've drawn out the Lewis structure, hopefully to make it a little bit more clear what's going on. So here we have phosphoric acid, H3PO4, and here we have the arsenic version of that, H3AsO4. So if you look here, the only difference between these two Lewis structures is one has phosphorus in the middle and one has arsenic in the middle. And we want to decide what makes this one of these two things more acidic than the other. And it turns out that phosphoric acid is more acidic. And here's why. The reason for this is that in this case, these oxygens that are attached to these hydrogens, these are the acidic protons, are drawing electron density away from the more electronegative phosphorus as compared to the arsenic. These oxygens don't have as much ability to draw electrons density away from the smaller, more electronegative phosphorus. Since they can't draw electron density away from the center as effectively as they can in the case of arsenic, they draw more of the electron density away from the hydrogen in this OH bond. The more the electron density in this OH bond is drawn towards oxygen, the more likely it is to break and for a proton to be lost and to end up with a minus charge on oxygen. So since this oxygen can't draw it away from the center as effectively as it can in this case, it draws it away from the hydrogen, weakening the hydrogen bond, making this more acidic. Simply stated, if you have a smaller, more electronegative atom in the center of two similar structures, that compound with the smaller, more electronegative atom will be more acidic. Let's look at another case. This is a little bit different. In this case, we have a bromine attached to two oxygens, and this is the acidic proton. And in this case, we have a bromine attached to four oxygens, and this is the acidic proton. This is similar to this case, but for a different reason. In this case, you have bromine in the middle both times. But in this case, over here, you only have two oxygens drawing electron density away from the bromine. In this case, you have four oxygens drawing electron density away from the bromine. It also, because these oxygens are lined up and it's equal in opposite directions in some ways, not exactly, but somewhat, it makes it even more difficult to draw electron density away from the central atom. The less this oxygen can draw electron density from the central atom, again, the more it'll draw it from the hydrogen. The more electron density drawn away from the hydrogen, the more acidic this proton. Generally speaking, if you have the same central atom, and in one case you have two oxygens, and in another case you have four oxygens, the one with more oxygens will be more acidic. That makes it this one. For the last case, I have to shift the paper up a bit here. We have H2SO3 and H2SeO3, and these are our two cases here. And this is very similar to the first example. They're both the same with three oxygens around the central atom. The difference is the central atom, is sulfur and selenium. So sulfur is smaller and more electronegative, just like, if you remember this case, phosphorus was smaller and more electronegative. Because it's smaller and more electronegative, these oxygens are less able to pull electron density away from it. Therefore, again, they pull more electron density away from the hydrogen, and that makes this hydrogen more acidic. So in this case, just like the first case, the one with the smaller, more electronegative central atom is going to be the one that is more acidic, like that.